डॉक्टर बाबासाहेब आंबेडकर ओपन युनिव्हर्सिटी.
Namaskar dear students, I am Dr. Himanshu Patel, working as an assistant professor in School of Computer Science of Dr. Babasaheb Ambedkar Open University. I welcome you all to the course on cross-platform application development using Flutter. I welcome you to this learning session on state management with Flutter. In this lecture, we will focus on powerful architectural pattern known as a BLOC, BLOC, which stands for Business Logic Component. Whether you are building simple apps or complex enterprise grade applications, understanding BLOC can help you keep your code clean, organized and testable. So let's get started. Let us discuss learning objectives. So by the end of this session, you will be confident in using BLOC in your Flutter apps. Here is what we are going to learn together. First, what BLOC is and why it is an essential tool in Flutter development. Second, how BLOC works through the use of events and state. How to use the Flutter_BLOC package to implement BLOC practically, and what are the best practices that make your BLOC code clean and scalable, and finally the limitation of BLOC so you know when not to use it. So let's start understanding the basics. So what is BLOC in Flutter? BLOC is a state management pattern based on streams and sinks. It helps you separate your business logic like processing data or reacting to user input from your user interface. Now let us understand why do we need BLOC. As Flutter apps grow, managing state using set state or even simple provider can get complicated. You need something more scalable and maintainable. So BLOCs provides a clear separation between user interface and logic, a predictable flow which is event, logic and state, and full control over how and when state update. There is a built-in support for streams. Now let us understand how it works. The user interface sends an event like button press to BLOC class. The BLOC receives this event, process it using your business logic and then emits a new state. The user interface listens to that state and rebuild automatically. Now think of it like a messaging system. The user interface talks to the logic layer and that logic layer replies back with the new state. Now let us understand why we need BLOC. In small apps, we often use set state to update the user interface. But as the app grows, using set state everywhere leads to meshy code. All the business logics get tangled with UI code, which is hard to test and maintain. So BLOC solves these by giving us a clear separation between user interface and logic and a predictable flow like event, then logic, then state. So we get full control over when and how your user interface rebuilds. And it takes advantage of Dart streams, making it highly reactive and efficient. So that's why BLOC is preferred for medium to large scale applications. For small applications, you can use provider or set state method. But for large applications, we must use BLOC. Let's walk through the BLOC flow step by step. The user interface sends an event. This could be a user action like tapping a button. Second, the BLOC receives the event and performs the business logic, for example, increasing a counter or fetching data from an API. Third, the BLOC then emits new state through a stream. And fourth, the user interface which listens to the state stream gets notified and rebuilt automatically to reflect the new state. Now, this event driven approach makes your app predictable and easy to debug. Now, let us try to understand key components of BLOC. So, on screen you can see key components. The BLOC pattern is built on 4 core components. event which represent something that happens like a tap or API request, state which represents the current state of the user interface like loading, success or error. The third component is block. This is the brain. It receives event and maps them to a new state. Then fourth is a user interface. This is your widget tree that reacts to state changes using widgets like block builder and block listener. These components works together to create a smooth reactive flow in your app. Now let us understand example. So on screen you can see example of shopping cart. So here we have displayed list of fruits like apple, banana and orange, and it can be added to cart by clicking on this add to cart button, and here on top you can see the cart. Here you can see list of items, and when we click on add to cart, it will be added to cart. Now cart reflects 1. Second item will change cart item to 2, and by clicking on the cart you can see different items added. By clicking on this delete item you can also delete cart item, and add to cart will add item to your cart, and by clicking on cart you can see the list of item added to your cart. So in this case we can say events are add product and remove product. What are the states? It contains list of product currently in the cart. And what is block role? It updates the state based on events like add or remove product. So it is a simple clean example. Understand the block. So we will write down code for these demonstration in Visual Studio Code to understand event, state and block. Now let us take second example. So first of all I will run these inside emulator. So I am clicking on run. So it will launch these inside this emulator. Now we have defined 5 files so that everything is easy to understand and separated. So here you can see my app is running, which initially displays my shopping cart with items added like apple, banana and orange, and when I click on this add to cart button it will be added to cart, and it also displays number of items available inside cart. Now it is updated to 2, and when I click on third it will be updated to 3, and when I click on this it will show all that item, and you can delete these items from cart. So now it displays 2. So this is how it works. So these item is defined by this class product. So first we will define one Dart file called product_model.dart, which defines a simple data model class named product. So this is a product. So it has a name and price. So inside class product I define one string variable name, which is a string that represent product name, and second I define one double type variable called price, which is a variable that represent product price. Here you can see this is my constructor, and both fields are required in order to create product object. So here I use required, and first is a name and second is also required, and its name is a price. So I hope you understand why we define this product class to represent this product inside my shopping list. Next we must define block class. So next I define one file which is cart_block.dart to define our block class. So here I must import this package product_model.dart to use that product class inside our file, and second we must import Flutter_block package which provides block functionalities, right? So here I write down import package Flutter_block and /Flutter_block.dart file. Now we have two events. So inside block we must define event and state. So what are the events? There are two events. Either you add product to cart or you remove product from the cart. So we must define one class called cart event, which is of type abstract. So here I define abstract class cart event. Now it is abstract. Why? Because it represents all possible events that can occur. In this case there are only two events, add or remove product from list or cart. So event class class is defined to handle adding a product to the cart. It contains product to be added. So here I define one class add product which extends this cart event, and inside that I define one object of type product. So inside that I define constructor to accept product. Whenever I call this add product and pass product type object, it will be stored inside these objects. Second, I define class remove product which extends cart event, and it has also one object of type product, and inside that I define constructor to accept product to be removed. So here is a constructor with object as argument. So these are my event add product and remove product. Now what are the states? Now whatever item is added inside this cart represent my state. So state represent the state of cart at any given time. Here there are only 2 products. Now when I click on these, my item is 3. So at any point of time, number of items available inside cart is my state. So here I define class cart state which has a list of type product and its name is products. Now this is my constructor which initialize this list to empty. So it is a constructor with default empty list if no product are provided. So initially this cart is empty. So my constructor will initialize my cart to empty list. Now we have defined event, we have defined add product class, remove product class, we have also defined cart state. Now there is a time to define block class which is cart block. So cart block is responsible for managing the cart state. It listens to the event like add product or remove product and emits a new state accordingly. And whenever new state is emitted, my user interface is updated or rebuilt. So here is a constructor to initialize the block with an initial empty cart state. Now inside that I must define on and then event called add product, and it has 2 arguments event and emit. So I must copy the current list of product and add the new one. So here I define one list which is updated list of type list to represent product, and here I call from method to copy existing state products. So whatever current products are there in cart is copied first and then we add new product which is added. So I call dot add and then event dot product. Now once that product is available in updated list, I must emit new state with the updated product list. So inside emit I write down cart state and I provide updated list as a argument. So my user interface is rendered with new list of items. Similarly, whenever some item is removed product from the cart, I must call on remove product. Again it takes 2 argument event and emit, and inside that I must copy current list of products and remove the specified product. So here I define one variable called updated list which represent list which is copied from current products list, and then I call remove method to remove that product from the list, and I must emit new state with the updated product list. So I call emit and inside that I provide cart state with updated list. So this is how my cart block underscore dart file will define event, state and block class. Now let us try to understand next file which is my product screen list. This is my product list screen. So here I have imported various packages like material.dart for using material design, flutter underscore block.dart to use block package, cart underscore block.dart to import custom block class and event state for managing cart state. Then I must import cart underscore screen.dart file, and finally we import product underscore model.dart. Now we will understand this cart underscore screen.dart file later on, but right now we understand these screens. So here I define class product list screen which extend stateless widget. So inside that initially I define 3 products apple, banana and orange. So here I define list of type product and its name is products, and it has a 3 item of type product and its values are apple and $1, banana and $0.5 and orange and $0.8, and then I call its constructor and define build method. Now inside build I must access cart block class from the widget. So here I define cart block object and here I write down context.read, and inside that I must call cart block instance so that we can use cart block instance from the widget tree. Now inside that I return scaffold, and inside that we have app bar with text set to shop that you can see here. So here you can see my title is set to shop that you can see here. Now inside these I define cart icon with dynamic badge showing the number of items. So here you can see cart icon. So inside actions I define first of all block builder, listen to cart block and rebuild when cart state change. So here I must define block builder with cart block and cart state type, and inside that I call builder method with context and state as argument. Now inside that I define tag, and my children's are first of all icon button which is of type shopping cart. So inside action I first display this icon, and whenever this cart is clicked it displays my item. So on press I must go to cart screen. So here I use navigator.push, and inside that I first provide context as argument, and second argument is material page root, and inside that we specify builder which returns cart screen. So whenever this button is tapped I must go to cart screen, that we will learn later on. But right now we remember that whenever this cart is clicked it will navigate me to cart screen. Now after that we must display this badge. Okay, so it represent number of item added to cart. So here I write down if state dot product is not empty. What does it mean? If there are some items are there in cart. So here I define position which is a right from 8 pixel and from top it is 8 pixel, and inside that I define circle avatar. So here you can see circle avatar with radius 10 and its background color is red that you can see, and inside that I want to display text which represent number of items in cart. So inside text I write down state.products.length which represent number of items in cart. So I display value of that inside this circle avatar, and then we must display this list. Okay, so inside body I create list view dot builder to create my list. Now how many items are there, which is represented by these products dot length. So number of products are there we must specify, and using item builder I can display these items. So inside that I define one object of type product which represent product at particular index. So we get product at current index. Initially it is 0, then 1 and then 2. So we must return list tile. So these entire represent list tile, and inside that in title I must display product name which is apple initially, then for 1 it is banana and for 2 it is orange. So first we display text with product name and price is displayed in subtitle. So here I write down subtitle and my text is a product price, but here I write down .toString as fixed with 2. So what does it do? It provides 2 decimal place. Here you can see there are 2 decimal places, right? After that in trailing I want to display one elevated button with text add to cart, and whenever this button is pressed I must add that product inside cart block object. So I call cart block dot add, and inside that I call add product class constructor, and inside that I provide product as a argument. So it will dispatch add product event to cart block, which in turn emits new state and my user interface is updated and its text is a add to cart. So this is my product underscore list underscore screen dot dart file. Now next, whenever this cart is clicked I must redirect it to this cart screen. So let us understand cart underscore screen dot dart file. So here again I import material dot dart package, then flutter underscore block dot dart package, and finally we import cart underscore block dot dart. Now we must define this cart screen. So here I define class cart screen which extend stateless widgets, this is my constructor, and inside build method I return scaffold, and inside app bar I display text your cart that you can see here. Now inside that I must use block builder, listen to cart block and rebuild the user interface when the state change. So here inside body, first I define block builder with cart block and cart state, and inside that I call builder method with context and state. Now if the cart is empty, we must display that cart is empty. For example, now it displays cart is empty. If product is empty, method will return true if there are no products. So here I display inside center that cart is empty. But what will happen if there are certain items are there inside cart? So we must display those items. So here I define return list view dot builder. This is again list view. So item count is represented by state dot products dot length, and inside that I must use item builder to display or create these items. Now inside that I define one product object which represent state dot product at specified index. So we get current index initially 0, then 1, then 2. So inside that I must return list tile. So here this is my product name and this is my delete icon. Inside list tile, in title I display text which is product name, and in trailing I display this icon which is a icon dot delete. Now what we want to do when this icon is pressed or tapped, inside on pressed I call context dot read and cart block of type cart block, and then I call add method, and inside that I provide argument or constructor remove product with specific product. It triggers remove product event to cart block. These line will trigger remove product event to cart block, which in turn updates our user interface. So this is my cart. So here we have used 5 files. First we understand this product model to define this product. Then we understand cart block which defines block class, state and events. Then we have product list screen to represent this screen, and whenever this cart is clicked we define this cart screen, and inside exe5_block dot we define our main method. So entire coding, user interface and logic is separated to easily understand the code. So I hope you understand this code, how to use blocks. So I hope you understand this demonstration. I suggest you to implement same functionality yourself. Let us discuss Flutter BLOC package. In Flutter, we use the Flutter_BLOC package to implement the block pattern more easily. These package provides several helpful tools like block provider, which is used to provide the block to the widget tree. There is a block builder which rebuilds the user interface based on the latest state, and there is a block listener which triggers side effects like showing a snake bar. Then there is a block consumer which is a combo of block builder and block listener. Now with these tools, block becomes much more Flutter friendly and easier to use in the real app. Now let us understand best practices for block. To get the most out of block, here are some best practices you should follow. First, name your events and states clearly and meaningfully. Second, keep each block file focused. Don't let it grow too big. Never write business logic in the user interface. Keep that inside the block. Use block consumer when you need both listening and rebuilding. Handle errors in state and show fallback user interface accordingly. You should use the quitable package so Flutter doesn't rebuild unnecessarily. Now these practice leads to scalable, testable and clean code. Now let us understand some of the limitations of block. While block is powerful, it is not perfect. Some limitations to be aware of are it can feel boilerplate heavy, especially for small apps. For simple small state changes, BLOC may be overkill. It has a steeper learning curve than provider. If not structured well, large blocks can become hard to maintain. So before using BLOC, ask yourself, do I really need this level of structure? If yes, then go for it. For simple user interface state, set state or provider might be enough. So let us sum up. Let us recap what we have learned. The BLOC pattern is a robust solution for managing complex state in Flutter. It follows a clean and predictable flow like event, logic and state and user interface. It promotes separation of concerns, making your app more modular and testable. With Flutter_BLOC package, you can implement BLOC effectively using tools like BLOC Provider and BLOC Builder. Start small, maybe with a counter app, and then scale up to more complex features like login, form validation or data fetch. So I hope you enjoy this video. Thank you and happy learning.